Welcome to solverfy.
All right, so here we are going to be using the binary search algorithm, and that's algorithm 3 in the textbook. Let's call it bind search. Of course, you can name it whatever makes sense to you. And we need for this algorithm a list of n integers. And it should be a non-empty list, so n ought to be greater than or equal to 1. Then we also need, in this case, we're not just searching for an element in the list, but we're searching for where to put the element. So that's the change that we're making. Rather than finding a pre-existing one, we're placing one in, and the element we'll be placing is x. And so this actually starts identical to the binary search algorithm, where we want to set our left endpoint of the search interval I equal to 1, and then our right endpoint of our search interval j equal to n. So initially we're setting it to the entire list here, and then we'll say while I is less than j, we're going to find the index of the point that is roughly halfway through. So we'll take I plus j, divide by 2, but then we floor it in case it's not an even number of elements in the list. And once we've done that, we want to compare x to this value that's halfway through. So we'll check and see if x is greater than the value of the mth element of the list. And if it is, then we want to reset our search endpoint. And we want to reset the left endpoint to be one further than the mth number. But if it's not greater than, then the assumption is that it's going to be less than or equal to, and so we would reset our rightmost left point then to be equal to m. Okay, and so far this is identical to the algorithm 3. And so what's going to change then is what we do after we've gone through this process. So rather than just finding the element, once you sort of narrow it down to one element here, in the previous case, the question was, is this element equal to x or not? So that was us saying it's either in the list at this location or it's not in the list at all. Here we're saying we've found the element that is greater than x, but the least greater than x. Okay, so then the question is x less than or equal to the element that we've found? Okay, and if we have, then the location is going to equal I. Okay, and so the only instance in which that wouldn't happen would be if nothing in the list is larger than x. And so if that's the case, well, then we just need to add x to the end of the list. So we'll set the location then equal to n plus 1. And at the end of this, we want to return. It's always good when you are writing your return case to double check what is it even that this algorithm is supposed to do, and it's supposed to determine the position in which to insert a new element. So we want to return the location, the position, right? Not the list.